Hi folks, my objectives with this video today is to summarize a few points about the LEDs that you started to play with this week, and also add on a couple of little facts that will help us account for some of the things that you have observed. LEDs, as you have already kind of come to discover, behave in some somewhat unexpected ways. One of the important pieces that we have uncovered is that, unlike the incandescent light bulbs, the standard typical light bulbs we've been dealing with, if you don't give these LEDs enough volts, they just won't turn on at all. It's not that they won't be, they'll just be like dim or something. It's just they don't work. But at the same time, too many volts and you'll kill them. And, we've seen that with our regular light bulbs as well, of course, but the tolerance, the limits here, are a lot more narrow than what we've seen for the other light bulbs. Your other light bulbs could handle really low voltage. A single battery would get them to light a little bit, and then you'd need like 9 volts to finally blow them. For a lot of our LEDs, we're looking at they need somewhere between 2 to maybe 3 volts is sort of ideal. Maybe you can go up beyond that, but even 3 batteries, which would give you 4.5 volts, was too much for some of our LEDs. So very much important to keep in mind. But we've also observed that they behave somewhat unexpectedly when we put them in series with other things. And I want to play around with that today. I'm going to work you through some calculations that are going to help illustrate some of the odd behavior of LEDs. We didn't have you do these calculations in class because they required some measurements. I had to take some of these measurements on my own with some equipment that is kind of a pain in the butt to use, so I did not have you do it. But here's some of the situations that you set up during Thursday's class. You hooked up the LED with one of the light bulbs and the buzzer. And you got to see that under certain conditions, depending on which LED you used and depending on how many batteries you used too, but you could get both of these things to go on at the same time. Same thing for the buzzer. And I had you speculate as to what that might mean for the resistance of the LED. And we're going to try to figure out exactly what this all means today using some numbers that I measured. I took some measurements of things that are going to help us out. Now, of course, when you were reasoning through some of these things, you were trying to make some comparisons, and you were using the knowledge that we have that in series, we've seen this before, the higher resistance component will essentially hog the volts. We've seen that happen before when we tried to hook up the buzzer and the bulb. Note that this buzzer has way more resistance than the bulb, and it basically took all the volts when we tried to put them together with each other. Well, what's going on with this LED, though? So because when we got both of these things to be lighting up at the same time, the buzzer going and the LED going, maybe that implies that they have somewhat similar resistances, but let's figure it out. Again, I took some measurements here. Here's what I was using. I was using the red LED. And here's what I found. I actually tried this thing out with 2 batteries, and this set up exactly. So here's my red LED and the bulb situation. And what I could measure here was I was able to measure how much electric current was going through that circuit while all those things were connected. So here's what I found out. With the bulb, my current, which I use my symbol I for, if you recall, was equal to 0.045 amps. Again, I just measured that. I have a device that lets me measure the amount of current going through. Okay, I'm going to run some calculations then at this point. I would like to know if this is true, what is the resistance of my LED? How many ohms must my LED have? There's a couple of ways I could actually approach this calculation, but perhaps the easiest is to set up the following equation. I know that the current is always equal to the amount of volts divided by the resistance. And for my series circuits, usually the easiest way to think about this is to think about it in terms of the total volts and the total resistance, because this current is going through the whole circuit. It's the same current, right? So my total volts in this particular case is 3. I am using 3 volts of batteries. And my resistance is equal to 30 from my bulb plus whatever the amount of ohms in my LED is. So I'm just going to put that down as plus the LED. And I know that that's got to equal 0.045. All right, all I have to do at this point is a little bit of algebra, and I can figure out what the resistance of the LED is. And let's go ahead and do that. So I know that 3 is equal to 0.045 times, I'm just multiplying both sides by the lower part of this fraction. All right, that means 3 is equal to, I'll take 0.045 times 30 times the LED. That means that if I subtract this from both sides, now I'm on 1.65 equals 0.045 times the LED. Okay, what is this? This one I can't do in my head. I'm going to actually use a calculator to figure out this part of it. According to this calculation, would have 36.7, I'll round it off, ohms. I'll verify that that is true. So back up in this equation up here, right, I should have 3 divided by 30 plus this should equal that. So I'll double check. 30 plus that is 66.7. And yep, that does indeed work. Okay, cool. So according to my calculation here, that's my resistance for my LED. All right, I also measured how much current I got with the buzzer. 0.0007 amps. Very small current. So I have the exact same situation as before, except instead of this setup, the 30 here was associated with my 30 ohm resistor. Now I have a 2000 ohm buzzer in the system. So my current, I'm going to use red for this part, just like I did over there. My current this time is smaller, 0.0007. That's going to be equal to my 3 volts divided this time by 2000 plus whatever my LED is. All right, same set of mathematics as before, right? We're going to just grind through it. 3 equals 0.0007 times 2000 plus whatever my LED is. Okay. I'm going to take 2,000 times that little decimal. I could do that in my head, but I want to make sure I don't screw it up since we're kind of dealing with small numbers and things, and that could be a problem. .6 then equals 0.0007 times the LED, and I just have to divide out this last one, 0.0007, and aha, my LED therefore has a resistance of, wait, holy crap. What the heck? Let's make sure I didn't screw this up right. If I add that to 2,000, I'm going to get like 4,286, 3 volts divided by that. Is that right? Yeah. Yeah, no, that's right. That's according to my measurements. That's what it is. Oh, but this makes no sense, because I just found over there that my LED has a resistance of like 30 something. What the heck is going on here? You can't have both of these at the same time, right? These numbers are radically different from one another. So this is all sorts of weird. This is all sorts of weird. All right, so what gives? What is the resistance really? Here's the weird part. It depends. And that is different than any other piece of equipment we've seen so far. The buzzer basically always has the same resistance. I mean, it's 2,000 ohms. That's just what it is. The light bulb, it's just 30 ohms. That's just what it is. The LED, well, it depends. It depended on what else we put into the circuit with it. It depended on how much current was going through it. But there is something that stays consistent here. And I want to show you exactly what that is. We found what the resistance was in these two different circumstances, knowing the current. And I want to come back to something. So in these calculations, I know the amount of current that was going through my circuit. I now know the resistance of the LED under those circumstances. In this situation here, I can find out how many volts the LED was getting. LED got how many volts? The current was 0.045 equals the number of volts divided by its resistance, 36.7 ohms. How many volts is that going to be? Well, it turns out that this is going to be 1.65. Okay. Over here, the situation was different. I had a much smaller current. 0.0007 equals the number of volts it was getting divided by its current in this case, which was 2286. How many volts does this turn out to be? 1.6. Now there's some little rounding errors and measurement errors here, but check this out. That is very similar. Here's what's weird. Here is what is interesting about the LEDs. They don't have a certain amount of ohms. It depends. What's the resistance really? It depends. Because what they do, unlike anything else we've seen, is they always, depending on what else you put into the circuit with them, they're always going to pull about the same number of volts in these series circuits. It doesn't matter if I put a low ohm resistor, the 30 ohm light bulb in this case, versus the 2,000 ohm buzzer, they pull about 1.6 volts in both cases here. really interesting. So this is one of those kind of key behaviors of the LEDs that we want to keep in mind as we go forward. What you're going to do in your task is I'm going to have you actually work through some similar sets of calculations to what I just did here, but with just some different measurements that I made, so you can get a feel for what I just did here and how I calculated some of these things out. So you'll get some practice working with these ideas. Note, I'm doing the same sort of calculations we were doing earlier this week, just with a slightly different set of known information than what we had before. It's the same equations though. I'm working with I equals V divided by R, and using the same principles that we've been working with for how series circuits work. So nothing radically new here, but we're using the ideas to figure out what's going on with this new piece of equipment. That's pretty cool. All right, that is it for this video.